And now let's start on that I2 reflection. You can see I've got the notes videos, and I'm going to put the solutions here and also a link to the Stapplet that I have for Scratchwork. And we also want to use a Stapplet for the t distribution. You can click on the link, but I'll just show you right now what it is, Stapplet. And you should have seen it in the notes if you did those. Hopefully you did. And that's the Stapplets for the t distribution. So it's just under, if you go back, it's under probability. There it is. Okay, so remember the degrees of freedom is sample size n minus 1. You have a sample size, so if you have a sample size of 20, what is the degrees of freedom? You go down by 1. It's 19. That's it. You have a sample size of 20 and want a 95% confidence level. What is the critical value? So we want to use the 19 from here and the 95% confidence interval. So we go 19 on degrees of freedom, plot the distribution. And because we know the area, we don't want an area, we want a value. So you see how it says calculate TC, that's your critical value. So we want to make sure we're calculating a value. And we want 95%. So we go over here and we go 0.95. Calculate value, and there, make sure it's centered. If it's not centered, it's not a nice confidence interval. I'm getting 2.093. Okay. You have a set of 10 data points with a mean of 350 and a standard deviation of 25. Which of the following is the appropriate 90% confidence interval? So that's another Stapplet you're going to want. So we're going to go ahead and go to Stapplet. And they're giving us data. So I need to be in the data analysis group. And it's only one quantitative variable. And you can actually click here and put mean and standard deviation. So you could put the mean, the standard deviation, and the sample size. So 350, 25, and our sample size is 10. 350, 25, sample size is 10. Oh, what are we looking at? It's just data. Doesn't say. No context. Oh my. All right. Begin analysis. And then they want what level of confidence? They want a 90%. So we go over here. So when I begin analysis, this is my only option because it's like, oh, you're using stats. We want a 90% confidence interval. And boom, 335.508 to 3364. You know what? I'll do a quick snapshot and put this in the Cami for anyone who is wondering, how do I do that? So I'll put that down here. So this is problem. Which problem is this? I probably should submit my answers. It's the last part of the new material. So whatever, part 1. And you know what? I'm going to go ahead and take a snapshot of this as well while we're at it. And put it in the Cami so people can see what I was using. So this is part 1. There you go. So there's the first one I did, and there's the second one I did. And the very first question was super easy. So what do we want? I think it's 335.5. Yep, that's it. So boom, and we'll go ahead and hit submit, see how we're doing. It's going to be a very short homework section. I hope you're okay with that, but you did take notes. So if other factors are held constant, which combination of sample characteristics would produce the narrowest interval? That should say narrowest. We want big samples and small variance. So that's what we want. So I'll go ahead and hit submit. Okay, now which combination of factors will definitely reduce the width of a confidence interval? Sounds like the previous question. A larger sample, but now we're adding in the level of confidence. So higher level of confidence, bigger interval. Lower level of confidence, narrower interval. But using a larger sample size always tightens it up. So we'll submit that. And, did I say increase? We want to decrease because we want larger sample, smaller confidence level. Helps if you click on the right one. Excuse me. You sampled 40 students and found they had an average GPA of 3.759. Which of the following, and you have a sample standard deviation of 0.56, which of the following shows a 95% confidence interval for the GPA for the population of students? So, because we're doing 95%, all right, then we're using 1.96 for our critical value. So we're kind of going off of this. Let me go ahead and just write it in here. Confidence interval is basically your statistic plus or minus your critical value times your standard error for your sample. All right, so that's how you create it. So the critical value in this case is 1.96. This is assuming we're using just a basic value. So you could say, but Mrs. Overman, we could try and use this on the t-distribution. We actually could, but we're kind of practicing an old thing that we learned. Our average was 3.79, so we can see it's either this one or this one. So the only difference between these two, this one's a standard deviation for the population, or for the sample, but we want it for the sampling distribution, so we have to divide it by the square root of the sample size. So the correct answer is that last one, or it better be. And boom. The only way I could make this better to reflect what today's lesson was is I could actually update that to a critical value using the t-distribution. Well, that's it. Feel free to share what you learned or what you struggled with right here.